Guys, the heading of what we did on Thursday was saying solving trig equations with more than one ratio. Now, obviously, this only has one ratio, right? It's a tan squared and a tan. So from that, you should be able to recognize that you're going to have to do some kind of factorized. Okay, because there's a constant term as well. That is a trinomial. Morning, guys. So what you have to do, remember for quadratic equation, you always have to get everything on the one side and equal to 0. So that would be your first step. That plus 2, you need to, or that positive 2, you need to move. Hi. Hello.
Space in this classroom.
And there's not enough space in the second.
There is one, but the stuff that teaching is too close from you. You don't have to teach. I know that can teach us.
Okay, that's good. I think that one is open. That's it there. All right, right here. Okay, guys, I'm just going to start from the beginning again because people came in late now. Right, you see there's a tan squared x and a tan x. Right, so it's obviously a quadratic equation, David. So you have to bring everything to the one side and make it equal to 0. Okay, that's step 1. Then that is a trinomial. Now, guys, I factorized it, but you probably wouldn't have wanted to do that. That's perfectly fine. You can use the quadratic equation, the quadratic formula, rather. Remember, we're not going to solve for x. Our variable here is not x. The variable is tan x. Okay, so if you're using the quadratic formula, you have to say tan x is equal to, then you have your whole thing, everything that you're subbing in. Then you will get those two values. Okay, tan x is 2/3 or tan x is -1. We find that step. So for this one, you didn't have to change anything. You didn't have to use any identities. You had tan squared and tan, so you could go from that straight away. Tan is positive in quadrant 1. I say I didn't write it there. Well, quadrant 1 and 3. But do we worry about the 3rd and 4th quadrants for tan? No. Okay, so we just have to do the quadrant 1 solution. You do shift tan of 2/3. You'll get your reference angle. In the first quadrant, x is just the reference angle plus 180n. Okay, fine with that one. For the next one here, tan is negative in quadrants 2 and 4. Again, we don't worry about quadrants 3 and 4 there for tan. We just have to do the 1 solution. So your reference angle is going to be shift tan of 1. Remember, positive 1. So you get your 45 degree. And how did I get to 135 here, guys? What did I do? 180 minus. Remember, in quadrant 2, we always do 180 minus the reference angle. Okay, so that's how I got to 135. Now, the extra thing in this question was that they said our x values had to lie between -180 and 360. So now you're going to sub in n values. All right, the first one that you always start with is 0. Okay, remember n has to be a whole number now, negative or positive, yes?
I'm going to see that. So this is going to be 315.
315, is that correct? Did I miss 315? Okay, thank you. I'll add that now. Sorry about that. Okay, so my first one, I made n equal to 0 in both of these. Okay, so then you just have 33.69 plus 0, which is 33.69. Then in your second one, if n is 0 here, that whole term is 0, so it's just 135. Okay, then I made n equal to 1, but I missed making n equal to 1 in this one somehow. So if n is equal to 1, you're going to say 33.69 plus 180 times 1, which is where I got this value from. You would do the same thing here. You would say 135 plus 180 times 1, which is where the 315 comes from, right? Sorry about that. If you make n equal to 2, you're going to add 360 to these values both times. So that will give you numbers that are too big. Okay, so n equals 2 will give you values that are outside of your boundary, the boundaries that they gave you. So n equals 2 is too big. Then you go backwards. -1 That's how I got those two values. Okay, if I made n equal to -1 there and n equal to -1 there, and then if you make n equal to -2, again, you'll be outside of your boundaries. Like I said, guys, if you're using this notation, this is set notation. If you're using these curly brackets, you don't have to write them in any particular order. Okay, so you can literally just write them down as you're finding them. So I would suggest that you do that. Guys, this extra step is usually just like 2 marks, right? And if you're leaving out one of those values, you'll lose one of those marks, unfortunately. So I would have gotten 1 out of 2 there because I left out 315. Okay. Any questions on that one, guys? Okay, let's look at number 6. For number 6, you just had to find the general solution. Now you would look at your first line, the one that was given. Do we see that we have a cos squared and we have a sine? All right, we need to get them to be the same. So the cos squared is the only one that you can change. So that one you're going to change to 1 minus sine squared x. Okay, are we fine with that? Now, guys, here you possibly would have just multiplied the 2 into the bracket immediately and then moved the term separately. That's perfectly fine. I just moved the whole term over and I made it -2. All right, but it doesn't matter. You would multiply the 3 into that bracket. You get 3 minus 3 sine squared x. Then I also multiplied the -2 in and I got that. And guys, again, because it's a quadratic equation, you need to get everything on the one side and make it equal to 0. Right, are we fine with that concept? Because there's a sine squared, we have to do that. Okay. Then I just work everything out here. So this was actually -3 sine squared x minus 2 sine x plus 1 equals 0, right? But then because I don't like having a negative a value, I just divide it through by -1. Then I factorized, but again, guys, it would have been fine if you use the quadratic formula. So if you look working with this, did you guys also divide through by -1 to get it like this? Okay, so you would have -2 plus or minus the square root of b squared, so 2 squared, minus 4a, which is 3, times c, which is -1, all over 2a, so that is 2 times 3. Okay, perfect. Remember, you have to show that step, please. Then you'll get your 2 sine x, what is this? Things, values, right? So sine x is a third and sine x is -1. For the first one, you work where sine is positive, quadrants 1 and 2. You get your reference angle. Quadrant 1 is just the reference angle plus 360n. Quadrant 2 is the reference angle, sorry, 180 minus the reference angle. So for this, you can say 180 minus 19.47. All right, and then plus 360n. Find this one here. For the next one, sine x equals -1. This is a strange one, right? Because it is negative. I think we can all see that. So we're going to have to work in quadrants 3 and 4. But guys, your reference angle this time is 90 degrees. Okay, which we actually haven't worked with before. We haven't had a reference angle of 90 degrees. Now, what are you going to do if you're working in the third quadrant? You have to say 180 plus the reference angle. But what's 180 plus 90? 270. And then if you work in quadrant 4, you're going to say 360 minus the reference angle. So 360 minus 90, which again is 270. Right? So your 2 quadrant solutions are getting you the same general solution, actually. Now, guys, let's quickly think of the graph of y equals sine x again. Y equals sine x. How does that one look again? Where does it start? It starts at the origin, hey, at 0. Then it goes up to 1 at 90. Goes back to 0 at 180, and then at 270, it is at -1. Okay, so for these ones that have funny reference angles, all right, you'll see sometimes you even get a reference angle of 0. Okay, that it can help if you think of the graph. So don't stress if you're getting the same solution for both quadrants, is what I'm trying to say. Okay, then think, oh, how does the graph actually look? it is equal to -1 at 270. Okay, so it's fine that you only have that one there. Any questions on that one, guys? How did this homework go? How are we feeling? Yeah, 12 was one of those funny ones, those tan ones. Oh, okay, well, we'll see now. Textbook issue again, I suppose. All right, number 10. So you're saying my 12 is nicer than yours. Okay, I'll look at that now. Okay, let's look at number 10, guys. That's also quite nice because we have a sine squared and a sine. So we don't have to change anything, all right? We are going to have a quadratic equation. So we know with a quadratic equation, get everything on the one side, make it equal to 0. Now what happened here is this one and that one on that side, if you bring this +1 over, it's going to become -1. So you're going to have 1 minus 1, right? So those ones are essentially canceling each other out, which is quite nice because in this case, that means we don't have a trinomial. We just have two terms, but both of our terms have a sine x in it. Okay, so that's what we're going to take out as a common factor. So 5 sine squared x divided by sine x is 5 sine x. Plus 3 sine x divided by sine x is plus 3. And that is then equal to 0. Now it's that same thing where if you have a product, two things equal to 0, you're going to take the one factor equal to 0 or the other one. So your first factor is just sine x, so you're going to make sine x equal to 0. And guys, remember, if it's equal to 0, it's not positive or negative. So now we have to think of the graph. All right, so I'm just going to add that here. Think of graph. Now we need to think of the graph of y equals sine x. We just spoke about that one. Hey, we need to find x values where that graph is equal to 0. Now we know that it starts at 0. Hey, it starts at the origin. So do you guys understand where this first one is coming from? Where is sine x equal to 0? At 0, at the origin. And then every 360 degrees after that. So that's the first one. But also remember, it starts at 0, goes up to 1 at 90, then it's back to 0 at 180. Okay, so that's where the second one comes from. Yes? Yes, you could have said that. Yeah. So guys, as a way of kind of putting these two equations together, don't worry if it doesn't make sense to you, but you could have just done this. Yes, that's fine. Robin?
So when it's values like 0 and 1, we don't have to think of the constant.
Yeah, you can think of the graph. Okay, for the next one, I left out some steps there. I'm just going to add them in here. So for making this bracket equal to 0, it's fine. Obviously, if you wrote all of those steps down, there's nothing wrong with that. So you would say either sine x must equal to 0 or the bracket must be equal to 0. Then you're going to take that 3 over, it's going to become -3. So you'll have 5 sine x equal to -3. And then you're going to have to divide by 5. Okay, so that's where that came from. Now this is a simple one, all right? It's like the ones that we've done from the beginning. Where is sine negative in quadrants 3 and 4? You find your reference angle by taking shift sign of the positive value, and you get that. Quadrant 3 is 180 plus this, which is where I got that from. And quadrant 4 is 360 minus this, which is where that one came from. Okay, and for this one, they also wanted specific solutions. So between -180 and 180. So there were only 4 there. Let me know if I left, oh, sorry, it's 5. Let me know if I left anything out there. So start by making n equal to 0 in both of your equations, then make n equal to 1, and then n equal to -1. Those were the only ones that worked in this case. Any questions, guys? Let me quickly check. 12. These are also my solutions from last year, I think. So let me see. This is a root 3, this one, yeah. Okay, so how is that going to change things now? So this will just be cos x. Let me actually just do it on a new page from the start instead of scribbling all over it. Okay, so 12. This one is 3 cos squared x plus root 3 sine x cos x equal to 0, right? Sorry, I did copy it down incorrectly. Okay, so we can see that we have two terms here, but luckily we have a cos x in both of them. Okay, so we're not going to have to change anything here. We can take cos x out as a common factor from the start. So we'll say cos x. All right, if we divide our first term by cos x, we're going to be left with 3 cos x plus our second term. If we take away that cos x, we're going to be left with root 3 sine x, and that is equal to 0. Okay, now same thing here. We have a product. Each factor is going to have to be equal to 0. So we're going to have to say cos x must equal 0, or this whole bracket, right? 3 cos x plus root 3 sine x equals 0. Okay, now let's quickly do this one first, the cos x equals 0. Remember, when it's 0, we need to just think of the graph of cos x. Where is that graph equal to 0? Jasper? Okay, do we all understand that? Remember, the cos graph starts at 1, right? Then it goes down to 0 at 90. So that's the first one. So x equals 90 plus 360n. And then n element of z. But that's just if this was the first one that you were doing. Okay, so don't worry about that. So that's the first time that the graph is equal to 0. Then at 180, it's -1. And then at 270, it goes back up to 0. Okay, so the other one is at 270 plus 360n. And guys, this is an example of why I thought it was important for you to know the shapes of the trig graphs instead of just using the table function every time. Okay, because now obviously can't just use, I suppose you can use the table function, but it helps if you are able to do those, find those two general solutions. Okay, now this one, guys, if you remember the example, the last one that we did in class on Thursday, I'll show you quickly. It's quite similar to this one, where we have this situation, 3 cos x minus sine x equals 0. Okay, it's very similar, right? Do we notice that? And then remember, what did I tell you guys? What are we looking out for? We have two different trig ratios. We have a sine and a cos. We can't actually change either one of these to the other one, all right? Because neither of them are squares. So because this is just sine x and that's just, sorry, this is just cos x and that is just sine x, we're going to have to turn it into a tan equation. Okay, so we need to be smart about this. We're going to have to move, let's move that one over so that we have the sine on this side. Because guys, remember, I want to change it into sine over cos. Okay, so let's move the cos to the other side. It's +3 cos x. So when I move it, it's going to become -3 cos x. Okay, so we have root 3 sine x equal to -3 cos x, like that. Now I want to get sine x over cos x. But do I want that root 3 on the left-hand side? No, I'm actually going to have to move the root 3 over as well. What am I doing with the root 3 here, guys? I am multiplying it by sine x. So when I move it, I'm going to have to divide by root 3. Okay, so we're actually going to do two moves. Does that make sense? I'm going to move this cos x over here so that I get sine x over cos x. Let me do that in one step rather. Or in two steps, I mean. So let's do the root 3 and then I'll do my sine x over cos x. You can do this in one step if that's fine. I just see some confused faces. Okay, that's the one shift that you're doing, right? You're dividing by cos x so that you get a tan x. but we want to get rid of that √3 as well. Okay, so I'm going to have to divide the other side by √3. So this becomes tan x, and that is equal to -3 over √3. Yes, it's one term. It's one term. Yeah, so you can write that at the top of the fraction if you want, or just in front. Okay. So guys, it's fine if you went from this straight to this step. If you just thought, okay, I'm going to divide by √3, I'm going to divide by cos. Okay, all at once. Are we fine with that? Some of you still look a bit confused, but do you see that it's similar to what we did on Thursday? Right? The only difference was on Thursday's one, we didn't have another number in front of the sine x. Okay, so we just did a divide by cos x, and we left the 3 where it was. Yes. You don't have to. No, you don't have to. Because guys, remember, what are we going to do with that number actually? We're just going to use it to find our reference angle. Okay, so it doesn't matter that there's a surd at the bottom there. Let me grab my calculator quickly. See what that is. Oh, where's tan negative? 2 and 4. Do we worry about the bottom ones? No. We're going to do shift tan 3 over √3. And that will give us our reference angle of 60. All right, so the reference angle is 60 degrees. So then for our quadrant 2 solution, we're going to say x is equal to, what do we do with the reference angle in the second quadrant? 180 minus. 180 minus 60 plus 360n, which is then just 120. Oh, sorry, yes, 180, thank you. Plus 180n, my bad. There we go. And for this one, they just wanted the general solution, hey? Yes, so that's it. Okay. Any other questions, guys, on any of these ones that we've just marked? All right. Ali, are you feeling a bit better now? Okay. All right, guys, new heading. We're doing a new type of equation today. Solving equations without a calculator. Not as bad as it sounds. It's actually quite nice. Okay. What do you mean? Since the beginning of the year? Yeah. Oh. Okay, we are solving equations without a calculator. Guys, let's ignore the without a calculator in the heading there quickly. What would you do if you got this equation and you were asked to solve it? We have actually worked with an equation that's similar to this one on the very first day. I think it was number 6 for yours. Not quite. I see where you're getting, but we're not really allowed to do that. Yes. If you saw something like this, hey, if we asked you this question, solve for x here. What is x? 12, hey, we can see because if the one side 3 times x is supposed to be equal to the other side 3 times 12, then obviously x must be 12. All right. So this is actually what's happening here, guys. They've given us the reference angle. But what I was talking about is, do you remember that small little worksheet that I gave you on the very first day? Let me just show you quickly which one I'm talking about. Was that Trig equations exercise? When we had this one, number 6, and you had to solve for this equation, remember what did I tell you guys? What are these things actually? Cos 71 and sine 17, they are actually numbers, right? Do you guys remember? So then you just move the cos 71 over to the other side, and you typed into your calculator sine 17 minus cos 71, and that gave you a number. Now, guys, if we were to do that here, that would be fine, unless, of course, the instruction said that you're not allowed to use a calculator. Sine 41 is just 0,656, whatever, right? So I'll just write here with a calculator. You would say that sine x is equal to, you would type sine 41 into the calculator, you would get 0,656, blah, blah, blah. And then what do we do from there to get the reference angle? Shift sine of this value, hey? So shift sine of the answer, and the reference angle is 41, right? Which is what we actually had here already. Okay, so I'm just going to write here. You would then say reference angle is shift sine of 0,656, which is then 41 degrees. Which is this number there. So guys, you need to actually be able to identify that. All right, if they've given you sine x is equal to sine of another number, they have actually already given you, not another number, sine of a number, they have already given you the reference angle. Okay, if they're saying sine x must be equal to sine 41, does it make sense that x must then be equal to 41? But because it's a trig equation, every 360 degrees after that as well. All right? And guys, what type of number is this? This is a positive number. This is a positive number, right? So we're going to have to work in the positive quadrants. Okay, but we need to recognize that the reference angle is given in the question. We don't have to actually work it out. In fact, if the question is saying without the use of a calculator and you do this, you're going to get 0 because you haven't followed the instructions. Okay, so let's write here without a calculator. I'm just going to rewrite the question. Sine x is equal to sine 41. Therefore, the reference angle is 41 degrees. Not just x, guys, but actually the reference angle. Okay, so if you just say x equals 41, that's incomplete. Okay, we have to still treat it as if it is, it is a trig equation, so we have to follow all those steps. It's also important that this is positive sine 41. So we're going to work in the quadrants where sine is positive. If that had been negative sine 41, like if there was literally a minus in front of that, right? If they had written negative sine 41, then we would work in the quadrants where sine is negative. Okay, so it will be quite easy to see when you have to work with the negative quadrant. Okay, what do we do in the first quadrant? X equals 41 degrees plus 360n. N element of integers. There we have our quadrant 1 solution. Quadrant 2, x is equal to 180 minus the reference angle, which is 41, plus 360n. Okay, we just need to simplify that. 180 minus 41 is 139. And that's it, guys. Okay, they didn't give us boundaries for x, so we're just doing the general solution. Yes.
So now for these questions, you would practically ask the solution.
Yeah. Yes, I suppose they can if it's not too difficult. Yeah. Okay, number 2. Sine x is equal to cos 20. Now remember, we're just going to do without the calculator now. Hey, sine x equals cos 20. What we do need to recognize straight away is that it's positive cos 20, right? Do we see that? There's no minus in front. So we're definitely going to work in the quadrants where sine is positive again. But can I now say that my reference angle is 20? It's not sine equals sine. Hey, it's sine equals cos. So what do you think we can do? I want to hear from someone else. James, yes? I'm not going to make it into 10. I can't this time because we don't have the same angles. Okay, if we had the same angles, we could do that. Yes? Yes. All right. I'm going to change cos 20 into sine 70. Do we remember our co-ratios? So sine x is equal to cos 20. This is going to be the same as sine of 90 minus 20. Or you can just write sine 70 straight away. Okay, I know the bracket is sometimes a bit confusing to some people. Remember, guys, if the two angles add up to 90, you can change the sine to cos or the cos to sine. All right, so this is going to be sine of 70 degrees. Cos 20 is the same as sine 70 because 20 and 70 add up to 90. Okay. Now what is my reference angle? 70. Good. Therefore, reference angle is equal to 70 degrees. Okay, from there, you're going to do your quadrant 1 solution. X is equal to, first quadrant, we just use the reference angle. So 70 plus 360n. Quadrant 2 solution, x is equal to 180 minus 70, hey? 180 minus 70 plus 360n, or you can just write 110 straight away if you want. We didn't touch the calculator, hey? That's quite nice. Now, guys, if you get stuck, all right, if you are not sure how the co-ratios work, I suppose I shouldn't really be telling you this, but you can kind of use the calculator to help you get there. All right, I'm recording this, I shouldn't be, but you could. If it says without the use of a calculator, I think you need to recognize, okay, I'm going to have to do like a change here or do this kind of reference angle thing. You can still do this, hey? Shift sign of cos 20, and it will show you that the reference angle is 70, and then maybe something will click and you'll think, oh yes, remember co-ratios. Okay, but guys, you will have to actually show this step. You'll get a mark for showing that. Okay, for physically showing that you're changing cos 20 to sine 70. You have to show that step. Okay. Number 3. Are we fine with this one, guys? Okay, now guys, what we need to see immediately is that this is cos is equal to positive cos, all right? I know we haven't done an example which is negative. I'll just change the next one to a negative one so that we have one of those. All right, but this is positive. Maybe let's just show that by doing a little copy there and just putting a plus. Okay, the only time that you will have to work in your negative quadrants is if there's literally a minus in front of the sine or the cos or the tan. Okay, so this is positive. So we're going to work in the quadrants where cos is positive, which is 1 and 4. But this one looks a bit different, hey, because we don't have cos of a number. We have cos of x plus 10. Now that is going to be our reference angle. Okay, the reference angle is going to be x plus 10, which is strange, all right? But does that make sense, guys? Because it's saying cos of this angle must be equal to cos of x plus 10 in quadrant 1 and in quadrant 4. Okay, so our reference angle now is going to include an x. Okay, which is weird, but we're going to deal with it. This is our reference angle. Okay, so therefore, I suppose I wrote it at the top there, so you wouldn't really have to write it again, but let's do our full layout. The reference angle is x plus 10. So in quadrant 1, my guys, can I now say x is equal to the reference angle? What angle do I have on the left here? Is it cos x? It's cos of 3x minus 20. All right, in the previous 2 examples, it was just sine x. So we just said x equals. And here we had sine x. So we just said x equals. Remember, if you have a more complicated angle on the left-hand side, that is what you need to write in your general solution. So we're going to have to say 3x minus 20 is equal to, right, the whole angle that was attached to that cos. Quadrant 1, it's equal to the reference angle, which is x plus 10 plus 360n. Now that looks very complicated. What must I do from there? Can I leave it like that? I do need to get just x equals, hey? So I'm going to have to move all the x terms to that side and all the constant terms to the other side. Okay, this positive x, if I move it, will become negative x. What is 3x minus x? 2x equal to, I have a 10 degrees over here. I need to move this minus 20 over. When I move it, it's going to become plus 20. What's 10 plus 20? 30 degrees. And we must remember our plus 360n. And now what must I do with that 2? Divide everything by 2. Okay, so I'm going to get x equals 15 degrees because 30 divided by 2 is 15 plus 180n. That is my quadrant 1 general solution. We still have to do one for quadrant 4, hey? Quadrant 4. Again, guys, the angle that was next to or that was attached to my cos, my original cos, is 3x minus 20. So I have to start with that. That is equal to, but now remember in the 4th quadrant, we have to say 360 minus the reference angle. Yes, Jasper?
Why can't we do negative, not negative plus, sorry, negative 15?
You can if you want to, yeah. You can do that if you want. I just don't prefer it that way, so I don't teach it like that, but it's fine. Okay, 360 minus the whole reference angle, guys. Because the reference angle consists of two terms, we have to please put that in brackets. Okay, because you have to minus the x and the 10. Let's simplify that first before we start moving things around. We have 360 minus x minus 10 plus 360n. Now we must move all the x's and all the numbers. Okay. I have 3x here. If I move this, negative x is going to become plus x. What's 3x plus x? 4x equals, we have 360 minus 10, which is 350, right? And then this minus 20 must also move. It's going to become plus 20. So 350 plus 20 is 370 plus 360n. Now guys, this is one of those cases where if you use your calculator to divide 370 by 4, I mean, I'm not going to know. Okay, so please don't sit there and think, oh, Ms. Form is going to know that I typed this into the calculator and I'm not going to get my marks. Do it. Okay, 370 divided by 4 is 92.5. Okay, don't try and do that in your head, guys. No one's going to know that you typed it in. 92.5 degrees plus 360 divided by 4, you can do though. Hey, what's that? 90. But guys, the key to this, before we had to do all of this algebra stuff over here, hey, I don't want us to get distracted by this. We can all solve for x, all right? It is a bit confusing because it's the first time that we've done one like this, but that's not the key to this question. The key to this question is the fact that we can recognize that we have cos of an angle and that we have to use that angle in our general solutions, very important, equal to positive cos of another angle, and this second angle is the reference angle. Okay, this is the most important part of this question. If you don't recognize this, you won't be able to do anything else. Okay, so very important, guys. And when they say you have to do it without the use of a calculator, you need to click, okay, I'm going to have a cos, and then the second one is going to be my reference angle. Right, it will always work like that. Any questions on that one, guys? I just want to do one last example quickly. Okay, can I go? Can I turn the page? All right, number 4. Cos 2x plus 30 is equal to sine x. Now guys, do you agree that even if we were allowed to use a calculator here, it wouldn't help us, right? Because what are you going to type in? Shift cos of x. Okay, that's not going to give you a reference angle. All right. So do we notice that this is on the right-hand side? This is positive, right? So we're going to work in the quadrants where cos, we always take the quadrant of the one on the left, where cos is positive. So again, that is 1 and 4. But can I now say that my reference angle is x? If I have a cos equals sine, I need to change this one to a cos as well. You can only say that the second angle is the reference angle if you have cos equals cos, or sine equals sine, or tan equals tan. So how can I change sine x to cos of something? Cos of 90 minus x. Again, we have to use our co-ratios. All right, sine of x is equal to cos of 90 minus x. You have to do that, guys. You have to have cos equals cos. Otherwise, you can't take that second angle as the reference angle. Okay, very important. What is my reference angle now? 90 minus x. So my reference angle is 90 minus x. What is the angle on the left? The angle that my general solutions has to start with, or have to start with, sorry, 2x plus 30. Okay, do that one on your own, please. Solve for x there on your own. You're going to do a quadrant 1 solution and a quadrant 4 solution. It's just like the previous one. Okay, looks like most people are pretty much done. Okay, there we go. That's what I got. For the first one, 20 plus 120n, because you have to divide by 3. And then for the second one, the quadrant 4 solution, 240 plus 360n. Because when you move this plus x, guys, that's important. Hey, a negative times a negative is a positive. When you move that over, it becomes minus. So 2x minus x is just x. So in that case, you didn't actually have to divide through by anything. Any questions there, guys? Okay, I would like you to do these 4 for homework, please. And guys, we've now actually covered all the different types of trig equations. All right, so tomorrow for the entire hour, I'm going to give you mixed ones. All right, because we've done a couple of different types of ones. You need to recognize which one is which. I'm going to give you a mixed exercise and you're just going to work on them for the whole hour. Okay, so we're done learning new things for now. We have to learn one last small thing at the end, but we need to finish this first. So I might teach you that in Wednesday's half hour so that on Thursday we can just practice all the trig mixed together. All right, because after this we're done with trig. On holiday. Yeah, so it's just if there's a minus in front. So guys, let's quickly look at the exercise that you have to do. I just want to show you one where there is actually a minus. For number 8, sorry, that's very small, but can you see there? It says cos x is equal to negative cos 42. Right? Do we notice that? Number 8, that's one of the ones that you have to do, hey? Cos x is equal to negative cos 42. So your reference angle is 42, but you're going to work in the quadrants where cos is negative. Okay, so guys, there will literally be a minus in front of the whole thing. Okay. Same thing here. You're not supposed to do number 10, but you can just look at how that looks. Sine x plus 10 is equal to negative sine 30 minus 2x. So it is sine equals sine. So that is your reference angle in brackets, but you would have to work in the quadrants where sine is negative. Okay, because there's a minus in front. You're not supposed to do number 10, you're supposed to do 9, but just for 8, please notice that you have to work in the negative quadrants. Okay, I'll leave that up. Yeah, I'll circle them now. 1, 4, 8, and 9. Okay, those are the ones that you're doing, please, guys. Get going now. You can do the first one in the time that's left, at least. Page 161. Yeah, 161.
One thing I'm just confused by is I attempted to